To all of you here in Paris and to all the people online attending this conference, welcome. My name is Thibaut Barrault, and I have the great pleasure to open this evening. First, I mean, this is obvious, but the whole event will be in English because even though most of the audience here is probably French-speaking, we have people online, and also I guess that with the Olympics, we force the world to listen to a lot of French, and we can outlive 2 hours of English. So thank you for this. And yes, so without further ado, I will start with the introduction to Pladifes. So Pladifes is actually the project behind this whole event. And I'm gonna just give you like a quick glance at the main outputs, and then I will leave the floor to the keynote speakers, and we'll end with 1 hour of roundtable with prestigious guests. So first of all, Pladifes. So yes, I know, yet another ugly acronym in sustainable finance, we know. But as you are all experienced sustainable finance practitioners, I guess that you are used to these kind of things. And I'm not gonna explicit the acronym. I'm just gonna focus on the objective. So the goal of the Pladifes project is to provide data accesses and data services to facilitate research both in finance and in green and stable finance. And here for this evening, we'll focus on the sustainable part, even if there is another part. So it's a project led by the Institut Louis Bachelier in partnership with the CNRS, the ESSEC Business School, and the Pôle Finance Innovation. It's funded by the ANR, and basically, to give you some ideas, we've been active since 2003 with Eurofide, which is a CNRS ESSEC laboratory, redistributing financial data to academics. And on the sustainable finance part, we've been active since 2022 with like the release of the ESG data cartography, which is an open tool available online, which was the focus of a previous event 2 years ago, also in the same kind of conference. So then I will just give you some ideas of the services that Pladifes can offer to you, depending on who you are. So for the second time, I'm just going to focus on the academics and on the practitioners, because this event is not really about data providers, even though we have some services for them too. So I mentioned it, but academics can access the Institut Louis Bachelier and the Eurofide databases. Eurofide databases being basically designed for them. And practitioners can also access most of the ILB databases, and they can also access tools like the ESG data cartography that I mentioned, but also like other kind of tools. If you want to know more about it, we will send you links after the conference, and you also have like flyers on some chairs for the people here in Paris. And for academics, we also have free data services, so it doesn't mean that we can work for free for everyone, but basically, if there is value and if there is a current partnership that can be found with academics, we can find a way to have a collaboration and to work with academics in order to work on projects that are usually win-win projects, because it helps them with their research and it helps us fostering the overall research in the field. And also we are organizing data sharing with academics. So to date, we have like 3 databases that we are redistributing. And these databases have been produced in the context of research papers, and they are available for free on our website. And it helps the academics getting citations, and it helps us, I mean, performing what we are supposed to do and getting a greater reach for this kind of research. For the practitioners, we have the thing that I already mentioned, and about the services, practitioners can actually access like a broad kind of services, especially on data and ESG through what we call the ILB labs. So these are 2 teams with 2 expertise, one on data and one on ESG, and they can accompany the practitioners through specific projects on either data, ESG, and also on mixed data ESG projects, which is really important, and which is, for example, what you are talking about tonight with data for sustainable finance. And of course, we are also open to patronizing option because this project, the goal is to outlive the public funding that we received first, and the idea is to be able to create a community that will be hopefully able to produce the great things. So then the idea is to give you some overview of what we call the ILB databases. So the goal is to have more and more databases. I'm going to start just by quickly mentioning our flagship product, so to say, which is CodeGem, and it stands for Corporate GHG Emission Estimations. So this is actually a project that will be developed more in details by Mohamed in a few minutes. So I'm just going to stop here for this. We also have a physical risk module. So it's a module with several databases, several projects in it. And this evening, we'll have the chance, I see Theo is arrived, so Theo will present his work on Katerina and on future damages tied to tropical cyclones. We also have like a significant focus on critical materials with already 2 databases available in open access through our website, and also incoming a great project on a critical raw material index that will be presented by Capucine also in a few minutes. And I will insist a little bit less on the other ones because they are maybe a bit less differentiating, but we also share ESG indicators. Also, some databases are only for academics through Eurofidays, and some are also accessible through the Pladifes website, but usually you already know where to find ESG indicators. We are also working on a carbon pricing index and on asset level emissions, and we already have the databases that you can access on our website. I invite you to check out the links, check out the databases. We are really open to receive any feedbacks. This project is kind of recent, so it's normal if everything can be improved, and we are waiting and not waiting for your outputs to improve everything. So that was really quick, but that was just to give you a small introduction about what is Pladifes. As you can see, we already have like a significant community of users, and it's not just within France and within universities. We try to work with as many people as possible. This is mostly for research, of course, but as I mentioned, we are also used to work with all kinds of practitioners. And this is just to end with the main context of the project. Of course, this kind of project makes sense if you are able to have a community and to exchange with people. It doesn't really make sense to have this kind of project on your own, and I hope that we will get some feedback in order to extend this community. And that was it for me. So, Mohamed, if you please.
So, hello everyone. Today I will share with you our work on our project CodeGem, focusing on estimating GHG emissions for corporates using statistical learning models. So, as we all know, with the growing awareness of around the climate changes, companies and governments and the researchers need to understand better their carbon footprint. So this project assesses this need by providing estimates for companies for Scope 1, Scope 2, and Scope 3. So the main objective of the project is to provide GHG emissions estimation for companies, whether it's Scope 1, direct emissions, Scope 2, the indirect emissions from electricity, or Scope 3, the indirect emissions from downstream or the supply chain. But however, we have encountered many key challenges, notably the lack of transparent and complete data, especially for scope 3. In addition, there is literally no public repositories working on this project, and also the literature on GHG emissions estimation is so sparse for the moment. And nevertheless, we have managed to develop models, machine learning models that estimate GHG emissions for companies. We have developed a database that estimates those emissions for 47,000 listed companies around all over the world and across all the sectors from 2005 to 2023. But unfortunately, the data is for non-commercial usage, but we believe it could be so helpful for researchers and practitioners. In the next slide, I will explain how we estimate the emissions. So in order to predict the emissions, we had to bring together different databases, sources, 5 database sources, 2 of which are proprietary, CDP and Refinitiv, and 3 that are open source. So CDP and Refinitiv are the central data set that contains financial and extra financial data for many companies that are so important as input for the training of our models. We also use data from World Bank. We use carbon pricing data and the gross national income. So it can give us an idea of how countries' policies assesses the GHG emissions. We also retrieve energy mix data from Ember. It calculates the carbon intensity of the produced energy, and it gives us a bigger picture of the indirect emissions. So once we have all this data, we go through a rigorous pre-processing steps. So I will not go through all the pre-processing steps, but I will mention the main one that distinguish our methodology. So for the information, those pre-processing steps are applied for the 4 targets: scope 1, scope 2, scope 3, and scope 1 to 3. We start by removing the extreme outliers values, and then we use a customized test train separation that take in account the biases, because as you know, the CDP and Refinitiv data is so biased in the level of the sectors and countries. There are so many big countries like USA and big sectors. That's why we use a train test that take into account the underrepresented countries and sectors. Then we impute the missing values using a sector average, and we select our features using based on the literature and many iterative tests. Once we do the pre-processing, we go to the modelization phase. So we have tested many machine learning models, but we have concluded that the CatBoost is a machine learning model, is the best performing one for 4 targets. So there is a breakdown of the metrics for the CatBoost. For example, for scope 1 and scope 2, we obtain a 0.92 R squared, which is relatively good and indicates that our models are highly accurate. But for the scope 3, we obtain 0.83, which is less accurate and which is so normal because there is less data for scope 3. And for scope 1 to 3, we obtain 0.9. And if we look at the plots, we can see that the scope 1 and scope 2 have a tendency that is kind of similar, and the data is packed into the middle, so which affirmates our metrics. For the scope 3, we can see that the small values are generally overestimated, but the big values are underestimated. And this is one of the points we want to improve. And also, it's the same thing for scope 1 to 3. So one of the improvements we have done in this year, we have used a new approach that uses the prediction estimates, that uses the prediction intervals. It's the prediction intervals is it's a range of values that the true emission can fall. And in our case, we have seen that around 90% of the values fall in the prediction interval, which is good. So if we look at the plots, we can see that the prediction interval for scope 1 and scope 2 is less wider than scope 3 and scope 1 to 3. And we can see also that there is more variance in scope 3 and scope 1 to 3. So to conclude, we have developed a methodology that estimates GHG emissions for corporates. The methodology is totally replicable and scalable. We have developed also an online calculator that calculates GHG emissions for not only listed companies, but also non-listed companies. So we are excited to share with you this work, and we're open to any improvement for the methodology and your feedback. So thank you so much for your attention. And I would love to share with you the database link, and the article link, and the GitHub link. Thank you so much.
Yeah, so we have a little bit, Mohamed. So we may have the time for one or two questions from the audience and maybe online. Not too much because we have a tight schedule, but if you have questions, feel free to ask them. Yeah, for the people online.
Thank you. Did you find a significant difference between explanatory variables between listed and unlisted companies?
Yeah, definitely. Because for the listed companies, we use data that is reported. But for the non-listed companies, we generally use like a model that is trained with less features. So there is less information. So the difference is kind of big. Yes.
I want to ask because you estimate the GHG emissions by the corporate. So my question is, have you aggregate them together and compare with the data at the country level or at sector level?
Yeah, the analysis I showed you is one of the analyses we did. So we've done many analyses on the robustness and the variances that is listed in the paper, scientific paper. So this one is done on the predicted values vs the actual values.
Your questions was about comparing the country level emissions with the company emissions, right?
Yes, just I want to know if there is gap between the aggregated, the corporate estimated GHG emissions and the country level reported GHG emissions.
Yeah. So the thing is that with the concept of carbon footprint, like you have a sum. If you take all the carbon footprints, you end up with more than the emissions because there is double counting. If you take the emissions for producing electricity, it will occur in the scope 1. It will also occur in the scope 2 that the people that are using the electricity, and it will also occur in the scope 3. So then you can use the carbon footprints of the countries. But another problem is that companies usually have activities in several countries because this model is mainly based on multinational companies that are listed. And then it's kind of hard you can't really just take the headquarter country and say that this country, this company's emission are tied to this country. So I guess it could be done, but it doesn't really make physical sense to do so.
Thank you.
Yes.
Did you compare the model performance among sectors?
Yes. So for the sectors, it depends on the scope. We've done another analysis on. We calculated the metric RMSE based on different scopes and based on different countries, but it really varies dependently on the scope. It's already mentioned in the paper in detail.
On which sectors it performs the best?
So for the scope 1, I guess it's the I don't remember, but I'm not sure about it.
No problem.
So yeah, there may be questions online, but I guess for the second time we're gonna switch to Capucine, and if we have time, we maybe come back to the questions later.
Yes, thank you, Thibault. So yes, so hello everyone. I'm really happy to be here and to have the opportunity to present to you our new index that we have constructed with my co-author Jean-Baptiste S. So this is the critical raw material index, and this is an index that has for purpose to track the price dynamics of materials related to energy transition. So the first question is why it is important and why do we need a new index. So the idea is that if we want to reach the Paris Agreement and if we want to move toward a clean energy economy, we need metals. We need metals because for clean energy technologies require more metal than conventional technologies. And therefore, if we need more metal, it will generate an increase in the demand. If the demand increases, it can create a risk of supply and demand bottleneck. So why? Because the supply is not really elastic. In many sectors, it's really long to open a new mine. Just for you to have an idea, it's roughly 18 years. So it can really generate a tension between supply and demand. And therefore, the risk is that metal price can increase a lot. And so, for instance, there is a study of Bowen Hall that showed that metal prices, in order to reach the net zero scenarios, can increase by more than several 100%. So, therefore, the idea is, okay, metal price will increase and so what? And so it will generate an increase in the cost of the energy transition. So it raises a lot of questions about that. What those will have an impact on on the energy transition, maybe it will delay the energy transition, and who's gonna pay for that? So that's why we need to understand better this transmission channel to act. And so we need a financial index that allows to track the price dynamics of metal related to energy transition. And this is what we propose today. So the critical raw material index is also, so our index is will be provided with full transparency regarding the method, regarding the data, the coding processes, and also the working paper will be available really soon on Pladifes website. And actually, we are also on a negotiation to see how it is possible to distribute the index. So now how we have construct this index. So the first question is, okay, so but actually what are critical metals for energy transition? So for that, we have select those that have been identified by the International Energy Agency database in 2024. And therefore, we got 29 metal price series. So this series are weekly spot prices from June 2016 to October 2023. And it covers a lot of clean energy sectors with electric vehicle, electricity network, grid battery storage, hydrogen technologies, solar PV, and wind. So we can find in the index like typical metal such as cobalt, copper, gallium, germanium, and so on. But the question was also how do we select the metals? What series should I pick? Because you have a lot of series with a lot of different names. So we have decided to create like different selection criteria. And the first one, the most important, is that we prefer to select metal prices that are quoted on global stock exchanges. And if we have not those series, we will select Chinese export prices. Why? Because simply metal markets are really opaque, and therefore not all metals are traded on global stock exchange. So you have a lot of metals that are traded over the counter, and the only database providers is in China. So, of course, we also look at the availability of the data, the daily price change of the series, and the form of the metal trade in order to match the most perfectly the form of the metal that is used in clean energy technologies. So now we have the data, but how do we construct this index technically? So we will use the guidebook from Nardo and Old regarding commodity price index. And therefore, one of the main questions when you are constructing a financial index is to decide what will be the weighting methodology. So it will influence the index. So the first one, which is quite conventional, is to use an equal weighting methodology. That is to say that you will just say that all the components in your index will have the same weight, but it is not really representative of the market. So therefore, we have also made a trade weighting scheme. So we have retrieved export volume of each metal that are in our index. And doing so, we are able to weight our index in function of the representation of each metal in the market. But the issue with that is that you have really huge heterogeneity in trading volume between metals. You don't trade the same, you don't have the same volume, for example, for copper and for lithium. This is really not comparable. But the risk is that you will have really high and big weight, for example, for copper and very low for lithium. That's why we also have include a cap to our index in order to avoid that our index is overrepresented by a market. And we have made two types of rate redistribution, like equally and proportionally. Okay. And yeah, the global export data, come from the BASI database. And the metal product code that we have selected has been selected in order to match the best the metal series that we have selected before. So here is the critical raw material index. This is in BAS 100, sorry. And we can see that it fluctuates during different time periods. So due to time constraint, I will just explain the last part. So from 2020 and 2022, we can see that there is a really big increase in the metal prices. And how can we explain that? This is just after the COVID-19. So we have a catching up effect with an increase in big increase in demand, also a strong growth, and of course in strong and robust governmental policies, with also an increase of interest in clean energy technologies. So a lot of things generating a higher demand and therefore higher prices. But also in 2022, we have, of course, the Russian and Ukraine crisis generating a strong shock on energy prices. So the index works for now pretty well, saying, okay, we have the ability to see what normally we need to see. So we have made also several sensitivity analysis. So our index is robust to is good in handling missing values. We also have made winterization process to address extreme values. And this is something that I really like. And it is also robust to variation in weighting methodology, but not from a financial approach, but from an economic approach. So the idea is that we have retrieved the market concentration of each metal, and we have ponderate our index by it. So this is more a weighting methodology regarding of the supply risk associated to each metal. So yeah. So now we have our index, but the question is, okay, but how do we know this is a good index? So we have followed the methodology of Caldara and Iacovello from 2022. And the idea is to, first of all, see if our index capture the historical evolution of critical material prices, so works well. And then how can we compare our index compared to other financial benchmark? So this is for the plausibility test. So on top of the historical analysis, we have just plot the return of our index. We have through two extreme lines, and we have just tried to explain what are the extreme value. And what we can see on this graph is that our index works like another financial index, so it will be driven by internal factors regarding clean energy technologies or mining market, but also external factors. So simply saying world economic tendencies. So we can see, for instance, that we capture the COVID-19 pandemic, Joe Biden election, but also China's stockpiling strategy, or here this is the Russia-Ukrainian war and the nickel crisis, because for those who don't know, following the Russian-Ukrainian war, the nickel has gone through a really hard crisis with an increase of its price up to 250%. So, yeah. So now about how our index work in comparison to others. The sole project that can exist that is close to ours is sub-indexes from the primary commodity price index from the EMF, and it is called ETM. But we have found that this index has several drawbacks, and one of the main limits of this index is that it doesn't include all the metals that are really needed for energy transition. For instance, you don't have graphite, you don't have gallium and germanium, and those metals are actually really in the center of notably geopolitical tension with different export restriction or announcement of export restriction on that metals. Also, our index is available on a weekly frequency. Their index is on a monthly frequency. We have made a lot of different weighting methodology, and one of the limits also in the ETM index is that it is only trade weighted, but without cap. So simply saying you have like big metal markets that drive a lot their index. Okay, so just for you to see, in red, this is our index. In blue, this is the ETM index. So we can see that it can move a lot, but you have difference at the end of the period. And the last question, and this is a question we had in a small committee when we were starting this study, was okay, but how your critical metal price index will really differ from the oil prices? And this is a good question, actually. But I'm really happy to tell you that, no, this is not the same. So, okay, I can breathe now. But of course, oil prices will drive and will have an impact on the critical metal price index, because it will have an impact on mining industry. But this is still different, and there are still internal factors in mining industry that is captured here in our index. So yeah, for that, the correlation coefficient is around 0.2, so really not high. Okay, so now is the time of the conclusion. So I hope you have understood that the critical raw material index is a new index designed to track the price dynamics of energy transition metal. This index is a necessary tool to better understand the current and future role of critical metals in the energy transition. And forthcoming, there will be really soon the working paper associated to this index on the Pladifes website, and we will also make with my co-author utility example with different, simply saying different application on how we can use this index. So thank you for your attention. And of course, I will really glad to answer to all your comments and questions. Is there any question in the room?
So thank you, Capucine. Can you go back to the code selection thing? Because I didn't get what you were talking about. What was the metal shape
Oh,
criteria?
for the selection criteria for metals, regarding how we, or this is for the selection of the different metal in the index, or how we identify which project code we need to weight our index.
I think it was the second one.
The first one?
Yes. The
Okay.
second one.
The second one. Okay. This one. So when you we actually making a trade weighting index, and so to apply different weight that is representative on the metal market, we retrieve export data of the metal, and to find the proper project code, because you have a lot of metal code. For instance, I don't know, for copper, you have maybe 20 lines of project code with different form of copper. And what do you select? It was a good question. So for instance, do you select the copper in its extraction phase, in refine phase, last product? So this was the question. And to have less less hazardous choice, we prefer to choose the product line that match the best match with the shape of the metal of the price series that we earlier select.
Okay, thank you. I have another question. It's about the index. I think I would expect the index to go up after the Ukraine, after the war in Ukraine.
Yeah, this is the case.
It's going down.
Now
No?
here in 2022, this is this point, and here this is the Ukrainian and Russian war. It goes really.
Okay. Okay.
It's a really spike.
Okay.
Increase spike. So yes.
Thank you.
It would have been complicated if not. Yeah.
Thank you, Capucine. This is a very exciting index. My question was related to what you said at the beginning. So you were saying that you are trying to make available more than just the index. So you're thinking about doing other things with it, or to actually try to make available also the original data. If you could develop a little bit more about that.
Yeah, sure. So actually, I don't think it will be possible to give the raw data associated to the index, but we will give in the paper where we have find the data, the name of the series, and the tickers associated to it. And so the database are mainly data stream. And yes, I think it's data stream. And maybe one or two series are Bloomberg, but that's all. But we cannot, it's private data, so we cannot give that. But the idea is more to give the final product with the different weighting methodology. So for now, we will see how it is possible. But even if in the worst case it is not possible, we will provide in our paper really everything to have the possibility to do it, that everyone can do it. So really the code, the data line, so you just have to download the data, the transparency in the method and so on.
Yes, so for the sake of time, we will have to move on, but if you want to exchange a little bit more with Capucine, it's of course feasible after the end of the conference. So I will leave the mic to Theo. Theo, thank you.
You can take.
Thank you.
Okay.
I'm going to talk about physical risks. So I will, after this very interesting presentation, show some beautiful pictures with maps and colorful maps. So in this presentation, we're going to focus on tropical cyclones. But first, before entering into the modeling of tropical cyclone and more broadly physical risks, it's important to talk about climate data. So climate data, we have several types of data. In fact, it's available online. We can download it, most of it. So we have reanalysis. Reanalysis, they are data that comes from models. So it's like gridded data with a lot of information about the climate. That is, these models are run with the information of historical data. So it really looks like the historical data. So it's ERA, MERA, and with this, we can access, in fact, a wide range of information about the past climate. We also have model data, the data that comes from the models that they call atmosphere and ocean general circulation models. These data, they come from physical models, so it's Navier-Stokes that installs in grids, and we have some information that it's not related with historical meteorological records, but we can have information about the future. So all this is accessible. So we have the coupled model and intercomparison project, CMIP, so CMIP 5, CMIP 6 now, that gives us a lot of information about future of the climate. So the question is why we're not building more physical risk assessment from this data? Because it's there. So we have, in fact, a lot of models that are available for floods, storms, droughts. And here I will detail a bit more the modeling of tropical cyclone and how we propose an algorithm that builds from this data some database of physical events with the case of tropical cyclones. So here is the model name, Katerina, because it's an algorithm including a thermodynamic module. I will talk a bit about that allows to assess damage at the national level. And this model, in fact, is, if we have to define it in a few steps, it's a model that is close to another model that has been developed called STORM, that will generate synthetic tracks. So they will initiate the tracks in points on the map similarly as they used to be in the past. These tracks will move similarly as they used to move. It's Coriolis, everything the planet should keep turning in the same way, although there is some changes, maybe. So all this is kept constant. And then we need to intensify the wind, the track, the pressure. So to do this, we know that the most influential variable is the sea surface temperature. So STORM does it already, and we will take it a bit further, taking other variables, such as the tropospheric temperature. So we take into account the thermodynamic efficiency of the available in the model, and also other variables, such as relative humidity and the mean surface pressure. So we will add more variables to better fit our model to what is available in the output of the climate models, in order to have something that really represents the future climate. And also, to go from these tracks to damage, we add little other steps. So we plug our tracks with a vulnerability assessment, much in line with the ClimaDA module. And we use some projection of exposure and of population that is also available. I will come back on this. So the output of this and the code will be available with some sample of tracks, gridded damage, national assessment and statistics on the Pladifes platform. So we are working on making everything available as soon as we can. Now I will deep dive a bit on the 3 steps of the modeling. So first, when we talk about physical risk, in general, we distinguish 3 steps. First, intensity of the event. The second will be exposure and then vulnerability. Or we can shift the two, I think. Depends on but start by the intensity. We have some track candidates that run on top of maps with climate data. So it provides a synthetic track that responds to the climate data. So this work, it's pretty straightforward. With the thermodynamic thing that runs everywhere. And based on these tracks, we can make some physical assessments. So we can see preliminary results from the CMIP 6 data. So we can run the same tracks in the historical or in different representative concentration pathways. And we can see that, well, it's not, we don't obtain the same statistics. So we can also convert into a written period assessment. But here is just a win percentile. And we can see that, well, it goes much worse. And we have some little red tumors everywhere on the map. So it's not cool. Okay, so now this is the intensification. So from this, we can build some models, some assessment of the risk. Now, if we want to take it as the national damage level, we need to have damage functions. So we introduce damage functions with a vulnerability parameter. So this little VH, does that work? I don't know how to use that. Okay, well, VH, it's the value of the win for which half of the property is lost. So the more it's the higher VH, the more the country is resilient. So Japan has a very high VH, and US don't have a very high VH because it's keep building the same house that breaks after each tropical cyclones. So this is the idea of the modeling. Oh, sorry. So vulnerability, okay. Intensity, okay. For exposure, we need to have an idea of how much we can lose on a grid. So to model this, well, we have the LeadPop project. It's part of the Climada, again, ecosystem. I did great work on physical risk, and so we use this database in order to have an idea of the local physical asset value. So basically, they downscale the money with lights. So where there is light, there is money, and if there is a tropical cyclone that goes there, well, there is more exposure potentially. In order to project this in the future, we need to use the growth of the GDP per capita and population in different places, with some assumptions. So this little alphas there means that maybe the growth of exposure may not increase as fast as the growth on GDP. It has been, in fact, in the past, see that every country but the US have managed to reduce their damage more than the GDP has grown. Not saying they won't be able to do it in the future, but we can adapt this. So now we have everything. So we have the little tracks. We can make them move in the map. We have the exposure. We have the vulnerability. So we just have to compute to sum over a Monte Carlo algorithm the annualized damage on the map. So that gives us estimates that are in line with observation in the past, and then we can make some projection in the future. So we have everything on the semi file. It's published result on the geoscientific model development, and for the next set of data and code that will be available on semipsis very soon. So we have the preliminary results here, so we can see increase also through time. That's it for me. I don't know if you have questions. Maybe it was fast, but it's over there. Okay.
Yes.
Hi, hello. Thank you very much for the presentation. So my name is Guillaume. I'm working at the Banque de France. So I have only one question for you. Up to what level can you narrow down the impact in terms of geographical location?
Well, it's a very good question. In fact, we will make available every gridded value of the damage. For now, it's on 125 degree. It's kind of crude, but we can narrow down. The thing is, the radius of the tropical cyclone is still quite wide. On average, it's 50 kilometers. So it doesn't really make sense to make it super precise. But I mean, it depends on the algorithm can run on a computer, and we can make it more thinner if we want. Just
Thank you.
Yes,
here.
Thank you. So you mentioned the Climada module. What would you say are the differences between your approach and what one may do in Climada?
Well, Well, when I started the project, the module of Climata were not using all the climate variables extracted along track on the atmosphere, ocean, and other GCM of SEMIPSIS. Maybe they have made some progress. I can't say exactly now, but the originally, yes, the improvement was mostly on the inclusion of more climate variable and on definition of maximum potential and intensity along track. So it's more like the thermodynamic part. On the damage part, in fact, it's pretty equivalent. We are using a similar approach.
Okay, and also on the exposure part, I guess, since they also use lead pub.
Yeah, exactly. So this part is very similar. What we have, it's more on the exposure projection that we will use SEDAC projection. The SEDAC is the Socioeconomic Data Center of Colombia. So we use gridded projection of population, but they probably have an equivalent as well. And the SSP as well. Well, I mean, everything is kind of the same ecosystems, but on the thermodynamic part was the most difference.
And is there some possibility to replace the exposure by one own exposure and simply use it? So it has the same modularity as also Climata would have. You could input your own.
The idea is, in fact, in this project we also play with other sectoral exposures, or you can just like put your assets on the map and see what is the frequency of being hit by a category 5 cyclone or whatever.
Okay, thanks.
Yes, so thank you very much, and thank you very much for the question. That was really appreciated. It's nice to have a detailed question like this. So I guess that was about it for the keynote speakers. So we're gonna switch to the roundtable. So I will invite Stéphane Voisin, Guillaume, Maria, and Imen.
Thank you.
Thank you, Theo.
Thank you, Thibaut, and thank you for the speakers. Very, very interesting. My name is Stéphane Voisin. I'm managing the Park Foundation, which include the Pladifes, and I'm also working together with the ESG Labs, which is our laboratory for data and ESG innovation. And I have the pleasure to moderate this session with a terrific lineup and a mix of people. I think that will be very interesting to move forward on the top questions. What are the missing data to progress and to go forward? So I will leave Maria, Eugenia, and Guillaume and Imen to introduce themselves. The idea is that we will leave each of them to make a short presentations on how they are basically using data and developing their own use case. And then we will focus afterwards on the missing data. Imen, the floor is yours.
Merci, Stéphane. I don't know if you can share my slides. Okay. Okay, great. So, okay. Thank you, Stéphane. Thank you for this invitation to this great panel to talk about this key question: which data are we missing to build a sustainable future? So this is a key question that we need to tackle for any transition strategy. Let me first introduce myself. So my name is Imen Benraja Bemza. I'm in charge of a data scientist team within BNP Paribas. My team is in charge of quantifying environmental risks for the bank. So today I will present you very briefly 2 R&D projects that we are working on to fill in 2 environmental data gaps. For each of them, I will present first the context, the issue, and this will allow you to understand a bit the use case that you are working on. The first example of our R&D project is a machine learning model that we are exploring to model EPCs missing in our portfolio. So I will Thank you. I will first present you the real estate sector, so brief overview, so that you understand the need here. So the real estate sector is responsible of 34% of global energy consumption and 37% of global greenhouse gas emissions, according to the IEA. The indirect emissions are linked to electricity consumption in the buildings, and this accounts for around 55% of global electricity consumption. Another interesting fact is that we expect the built surface to be equal to 230 billion of square meters during the 40 next years, which is equivalent to building a surface equal to Paris city surface every week during the 40 next years. So this is huge. This gives you an idea of the climate relevance of this sector. And this is this is one of the sectors that we need to cover within our climate commitment. So we need to define a target to decarbonize our real estate portfolios. So how does it work? So basically, we need to compute the average climate performance of the portfolio. We need to monitor it year on year and demonstrate that it is following the decarbonization pathway that we committed to follow. But how to do that? Let's take, for example, the French mortgage portfolio. We need to get the energy performance of each asset financed by the portfolio and to compute the average. So it looks easy, but not really. Actually, in France, we are quite lucky because ADEME, the French Energy Transition Agency, is centralizing since 2013 energy performance certificates, so diagnostic de performance énergétique, and it is available in open source. So this is huge. By the way, we don't have that in every country in Europe, like in Belgium, for example. But still, so we have this data available in open source, but it only covers less than half of French buildings. What could we do with the remaining buildings? That's where we need the model. So we tested two different models. The first one is a basic form of KNN, a key nearest neighbors model, which only uses ADEME data. So for the target building, we only look at the dwellings located within a certain radius around the targeted dwelling. And we only select the dwellings of the same category of the building for which we look for the energy performance. We compute the average of those EPCs, and it gives us a first estimation of the dwelling's energy performance. We then tested a second model, a more sophisticated one, based on classification algorithms, but we had to acquire additional data. So we bought a notary database, which includes basically around 20 features, 20 physical features of the buildings, like number of windows, number of bathrooms, surface area, year of construction, etc. And we use that data to model missing energy performances. And we demonstrated that machine learning is a better model, so it has a better performance than the basic KNN model. We described our models, our results in a research paper that is available in open source, by the way, if you are interested in the results. So that's for the first example. The second example is a project that explores satellite images to quantify methane emissions from oil and gas infrastructures. First, a bit of context to understand the need here. So methane is the second most abundant greenhouse gas after carbon dioxide. It represents around 16% of global greenhouse gas emissions in the atmosphere. And it is 28 times more potent than carbon dioxide, which means that it traps more heat in the atmosphere than carbon dioxide. So that's for the gas itself. In terms of sources of methane, 40% of methane sources are natural sources, and the 60% remaining emissions are described here in the graph. So the two main sources are agriculture and energy, and each of them is responsible of 40% of anthropogenic methane emissions. Within energy methane emissions, sorry, oil and gas is responsible of 60% of these emissions. So we worked on this project to quantify methane emissions from oil and gas infrastructure. So what you can see here is the process that we follow to quantify methane emissions. So first step is to acquire the data from commercial and public satellites like Sentinel-5P that is able to detect methane emissions. Second step is image processing. So we use advanced algorithms to detect obstacles to methane detection. And we discard images with more than 15% of pixels that are covered by clouds. And by the way, there are other obstacles like snow, like water that reflect the sunlight, which interferes with methane measurements. Third step is methane detection. So we analyze those images and measure the methane concentration in each pixel of the image. Then we isolate areas with the highest concentration of methane. That's what we call plumes of methane. And the last step is to quantify those emissions and to locate the source of the methane leak. So we worked in partnership with a startup specialized in satellite images processing, and we are working on a research paper that will be available in open source in the coming months. So stay tuned.
Thank you, Imen. Very, very interesting. It's very interesting that the two use cases that you just told us about are two related to what we call alternative data sets, and not to, let's say, regulated or corporate data sets. So does that mean that you think, and I'm talking to you not only as a responsible for this use case, but also as I know you are, overall at BNP Paribas, you're responsible for all the ESG methodologies. Does that mean that we still need to rely on, you think in the future we'll have to rely on this alternative data beyond the regulated data, and we expect, of course, the regulated data to improve in the future with increasing regulation on potentially CSRD, or do you think is going to be more balance between regulated and alternative data, because most of what you proposed just now is based on alternative data?
Yes, indeed. Actually, I wanted to just to have a positive angle on this issue, because it's a big issue. We are really lacking environmental data. And the best source of environmental data is the data that is measured by the company itself, because we don't know. These are all modeling alternatives. So there is a huge modeling uncertainty behind. That's just to give you an idea that we are not just waiting for companies to improve their environmental disclosures. But the golden source would be the disclosures of companies that need to be more available, more standardized, more granular. So that's the future, by the way. Here, this is an intermediary step, let's say.
And just a curiosity, you've been mentioning a startup you've been working on methane emission. I know with the labs we've been working with on this almost similar use case with Kairos. Are we talking about the same company? Okay. Interesting. Okay, they made a lot of noise. Okay, no, but at the ESG labs we share a number of common scientific background with Kairos, and we try to work together with them. Let's move to the Banque de France and to Guillaume with a different type of use case. You're responsible for a new project at Banque de France, which is a very important one by its coverage and by its innovation. I'll leave it to talk about it. Thank you, Guillaume.
Thank you, and for all the presentation that have already been presented, because it's very important for us to have this type of forum when we can share our project and share how everybody is improving and how we can all work together for a sustainable future, which is the title. What data are we missing to be the sustainable future? On my part, when I saw the title, I felt it was a very, very ambitious project. So let me first start by narrowing it down a bit to make sure that I might be able at one point answering the question. So I'm only talking so far about our project, which is called the Climate Index for Companies at the Banque de France, which is a division I'm heading for the past months only so far. So please be tolerant with me on the issue. But it's still an ambitious project. Why is it ambitious only to talk about climate for companies? Because the slope is already very steep. Scientists rang the bell early enough, but it took time to act for everybody. So the slope is steep. We don't have much time to climb it. Democratic expectations are high, and we need to act fast in order to be potentially able to be back on track for to reach the Paris Accord. And so the slope is steep. We don't have much time to climb it, and it is icy. And it is icy because what we absolutely want to avoid is any kind of greenwashing. So within all we are doing at the Banque de France in terms of green finance, we can talk about greening monetary policy, for instance. We can talk about supervision. Some of my colleagues are working more towards academics. I see another familiar faces in the back. What we are trying to do on our side is to help companies position themselves towards sustainable futures. That means reaching the Paris Accord. So let me start with what we want to do. So basically, the climate index, the Banque de France climate indicator or climate index has 3 dimensions. So I'm talking only about French companies so far. The 3 dimensions are the usual one: transition risk indicator, physical risk indicator, and maturity indicator. For the transition part, basically, we are trying sector by sector. And when I'm talking about sector, I'm not talking about the INSEE sector, but the ADEME sector, so where we have a methodology to assess the company situation in terms of transition. So we position the company and we compare it to a benchmark, a sectoral benchmark that is solid enough to have a forward-looking perspective. So we try to project the transition path for the company up to 3 to 5 years. It's mostly to 3 years. So this is for the transition risk indicator. For the physical risk indicator, we locate the company. So this is why I was asking the question on to what level you can narrow it down. So far, we reach like 8 kilometer to 8 kilometer, and we're looking at so 4 to 6 climate hazards, basically. And the purpose is as well to be able to project the company situation up to 3 to 5 years. And the maturity indicator, so this is something that normally people are more familiar with, is looking at the strategy, for instance, and how it is how climate situation is embedded in the strategy of the company, to be very quick. What kind of data do we need to do that? Basically, thanks mostly to all the work that have already been done and achieved and lifted by most of the people that are here, we don't need that much of data to do that. So this is, you mentioned a new project, but basically we started 2 years ago, and now we said, so we are producing, so we have stabilized the methodology for 3 sectors: real estate, electricity producer, and transportation. And we tested 10 other sectors. So we have been testing 10 other sectors for in 2023 and this year as well. And hopefully we might be able to stabilize the methodology for at least 2 more sectors, maybe 4 up to 4 more sectors. One of the sectors, and I was very interested by your presentation, you meant as a whole, but specific for the graph you mentioned, it's potentially agriculture. And so if my big boss agree on it, maybe we can stabilize the methodology on it, which will be a huge step to help transition the French economic overall. So for transition risk, as you can see, for instance, for real sector, we need, so first info, the stock of square meter, associated GHG emission, the flow of square meters, and the year of implementation. This is to project up to 3 years. So that means 4 information. It's a little bit more for electricity producer. We are looking at 5 information. For physical risk, this is very tricky. It's very tricky. So thanks to all the data providers in France, so you mentioned ADEME, for instance, but INSEE as well is a very, very great data producer for France with very robust statistics. With the CIRET, and then we can cross-reference the CIRET with all RCP. We're looking at for RCP of 4.5. We can try to project the climate hazards for companies. So that is not that much of information. But as it has been mentioned, it's not because the number is low that it's easy to get them. And I will get back on that a little bit further. We need as well some financial data. One of the main aspect we think about our climate indicator is to be able to assess what we call, as you know, tangible actions. And in order to say to a company, all our activity is related to be face-to-face to a company and say, look, you are on track or you are not on track. And when you have a company in front of you on one-to-one, you need to be sure about what you are saying. So all we have to do, we need to be able to assess what they are doing. So we ask for financial data, so OPEX, CAPEX, outstanding amount of the project, type of financing, and amount still to be funded. In a situation where interest rates went high and then they are starting to lower a bit, we have at the Banque de France, fortunately for a central bank, ability to get information of the cost of funding. So that's the easy part for us. And we ask as well some qualitative data, mostly related to the maturity index, but that flows back into transition risk and physical risk. How do you assess your GHG emissions, of course? The level of climate change literacy I spoke about. We speak a little bit about beyond climate, the impact on environment and biodiversity, but this is very, very, like it's an early work. So what data do we need? What data do we have so far? So this is a representation of one of the many work that the Institut Louis Bachelier has achieved. So this is the ESG database. But this is one example of all the work that has already been done and all the data that are already existing. We rely as much as possible on public data and on robust data that we can track, that we can be sure that it's the right one. Again, our whole purpose is to go to have a meeting with the company and say, in one sector, one company, are you on track or are you not on track? So what data do we need? What data do we have so far? But the question, the big one was, what data are we missing? And hopefully you won't hold a grudge against me, because I'm finally reaching the topic of this roundtable, but only at the end of the presentation. Basically, we already have many data, ADEME, BGS, EIA, C4F, etc., etc. CRCD reports to come, and it will be a huge help as well to assess tangible actions. So what we do, and we're looking at, it's a little bit old school, basically. So what we do, and it's especially to bridge the gap on tangible actions currently, where we still not have much proper data on it, we simply, with quotes on simply, we ask to the company to tell us what are the tangible actions currently in motion, and ask to prove that are the proper tangible action. So we have a direct data collection with each company, direct discussion with each company. And of course, all this purpose of the climate indicator is basically to help the company. So we try as much as possible to lower the reporting burden for companies. Still, I just want to stress two aspects in terms of data missing. So the first thing, and this is why currently we ask the company, so we lack certified data on climate. So this is why we are really looking forward to CSRD report, ESRS reporting as well, that will be precise enough to help all companies in France and potentially across Europe to be on track for the ecological transition. So this is the first thing. For instance, we are very happy and we are very supportive of the work that is currently undergoing by auditor through the Haute Autorité de l'Audit, for instance. It's very important for each company to be able to have like auditors that are able to certify the data. So this is the first thing that we are still missing. The second thing, of course, and I mentioned it very quickly, are all the environmental aspects beyond climate, and I'm talking as well about biodiversity. To conclude very quickly, and I would be happy to take question afterwards, maybe after the roundtable when we are drinking some champagne. There is some champagne. Okay. So landscape appears less and less scattered for climate finance, thanks to all the work already lifted by many counterparts. So thanks a lot to everybody. Many things are still to be made to reach a world that is matching, of course, the ambition set by the Paris Accord. Institut Louis Bachelier, among others, private banks, academics have filled a gap. We try within the Banque de France to fill another one, because we believe that companies are key link to make sure that we reach a sustainable future. Thanks a lot.
Thank you. Thank you very much, Guillaume, and thank you for referencing the Pladifes ESG database, the one and only ESG database, which is a mother of database. It's referencing all the other database. One question, I mean, it seems that you're going the coverage is extremely granular. I heard about a target of more than 300,000 French companies. And I understand that you are you're not pulling the data, but you're pushing companies, and you have the pressure, obviously, as a supervisor to get this data. To some extent, my question is related to the use of proxies. Are you intending basically to achieve such a coverage, to use proxies to basically fill the gaps on a sectorial or geographical basis, or not? Are you really intending to get all the data from all these companies?
As we are not trying to cover yet 300,000 companies, even though that would be a very big achievement. So basically 300,000 companies is our coverage related to the credit rating that the Banque de France is providing to each company. 300,000 companies in France, that's roughly 80–90% of the value added of France. So that would be a huge lever in terms of transformation and on ecological transition. We are not able to do that. So far, for instance, I presented to you 3 sectors that where the methodology is stabilized. We think that it's covering roughly 2,000 companies. So to go back to your question, this is why we can try to access raw data without passing by proxy. But if the coverage is expanded. And when I'm looking at the 2,000 companies, we are, as you have maybe heard through the presentation, we are very focused on transition risk, which takes with it physical risk and as well maturity risk. But we are currently discussing the ability of separating everything. So the coverage for transition risk, where we need like a very robust methodology as well for physical risk. So of course, the focus on companies is lower. For maturity, many we could be able to go wider, but still the purpose is to ask the company, because we really want to make sure that they are embedded in their own transition path.
Thank you, and I will come back to you with a round-on question and to Imen as well. But last but not least, it always comes last, biodiversity. So I said last but not least. Maria Eugenia, what's your take on biodiversity at the share economy du climat, and what are the missing data?
Okay, thank you. So thank you, everybody, and thank you for the presentations we had today. My name is Maria Eugenia Zanin, and I'm a researcher. So I'm sorry for my slides, which are very boring as compared to everybody else's. But I'm going to tackle a very pressing topic that and a very recent topic. So as we were saying, I'm a researcher at Paris-Saclay and associated to the Chaire Climat, so I'm well known here in this home. And so I'm interested in biodiversity because I'm going to try to convince you that this is a very important climate physical risk. And so I'm going to show you how we can use research to actually tackle this and somehow give biodiversity this definition, so we can afterwards include this and talk about it in a more financial type of way. So I probably don't need to explain what financial climate risk is to this crowd. We know that we have, it's important that we know that it has a very recent history. So it's a recent topic. And we usually talk about three types of of risk: physical, transition, and liability risk. And mostly in finance, we care about the first two. In terms of why do I say that biodiversity is, so in particular biodiversity degradation or biodiversity loss is one form of climate physical risk? Because as you probably heard from the European Environmental Agency, the loss of biodiversity can exacerbate climate-related risks. And so firms are less resilient to climate change. But also this second point I tackled there is the economic system dependency on biodiversity. So there are several papers that show that more than half of the world GDP's production depends actually on ecosystem services, so on biodiversity. So the problem is that indeed this is difficult to consider in economic calculations, it's difficult to measure, and we have been having problems to actually price it, right? So in France, we started looking in a deep dive in biodiversity very recently, and even if in Banque de France there are very interesting papers that talk about, for example, this 42% of the value of securities held by French financial institutions come from issuers that actually are highly dependent on ecosystem services. But even if we understand this, we actually firms have difficulty in incorporating this into their calculations. And there are some research papers very well published in the Journal of Finance that actually show that market participants do not incorporate the current pricing of biodiversity in their strategies, in their equities. It's not properly priced in markets, so on and so forth. So for a research project we actually built this biodiversity index that we had the pleasure to share with Pladifes. And so the reason why we believe this index is interesting is that, as you know, there's research showing that exposure to climate physical risk means that firms have lower profitability and lower market returns. And therefore, if we agree that biodiversity, so if you believe my previous slide where I actually showed that GDP is dependent on biodiversity, well, if we are exposed to biodiversity risk, these firms are also most probably are going to have problems regarding economic issues, right? And so in the paper that gave birth to, so it's the reason why we build this data, we actually show, we use the index and the trend I'm going to explain later, to actually show that indeed firms' profitability is significantly dependent on biodiversity risk exposure, that the financial market has not yet incorporated this efficiently, and that, of course, different firms, firms belonging to different sectors are exposed differently. So, of course, there are some sectors that are not exposed, but there are some sectors like the agricultural sector and that is exposed. So let me give you some a flavor of this data and what you can find. So basically, we first have this biodiversity footprint measure that actually considers the production in tons per year in a single country in one land use category, and those land use categories are the 6 that are listed there. So, of course, we have cropland, wasteland, and we have the 6th one is interesting because it relates to what we talked until now. We also consider forest carbon uptake, so CO2 sequestration. And so we see this production in these type of categories as compared to the world average yield for this land use category. So this would be the footprint, to which extent a single country exploits its biodiversity as compared to the average on this same category if they had an equivalent area. Then we have the biodiversity capacity, which is actually the area in that country for this land use, times the national average yield for the land use category, as compared to the world average, right? So, of course, some countries like Brazil may have more capacity than some countries as compared to France, for example, right? And so comparing the exploitation or the footprint with the capacity, we build this index that is biocapacity over footprint. And of course, this means that if this index is superior to 1, the biological resilience overweights the destruction of biodiversity and vice versa. So we have more capacity than what we are using and vice versa. Okay, and so this, we do it at the country level, and this data is done at the country level. So regarding the disaggregation, but the source data is actually more disaggregated. This was not the purpose here, because we wanted to show that indeed, in average in the markets, in any case, we can observe that firms present in these markets indeed are affected. But what is most interesting to you here, which are concerned about physical risk, is mostly this biodiversity trend, right? Because what we assume in this work is that biodiversity is autocorrelated, and so if there were no surprises, the biodiversity we observe at a certain year should be perfectly explained by the biodiversity we observed in the previous year, and so on and so forth, mostly because indeed biodiversity is something that its impact in the economy, it degrades in trend, right? It's a long-term problem. And so we estimated this 30-year rolling estimation of this trend, this beta 1 CT. And so if this beta is different from 0, it means that there is some risk, there is some surprise in this biodiversity. And so we may have a long-term degradation or a long-term improvement if this trend is indeed in the other way around. And so just to give you a flavor of what we find, so this is the biodiversity index, the value of the index. And so we have in green countries that have an index that is higher than 1, and red the countries that have in average an index lower than 1. So we consider the main 35 economies in the world, and we find that most economies have indeed, in average, a degrading biodiversity. But if we look into the trend, that is this trend over the 30-year rolling window, we observe that biodiversity is degrading in most countries. And it's funny because, as you can see, the greener country is France in that. So we can discuss about that later. There are the green ones are indeed here in Europe, which is somehow good news. Then we can discuss about to which extent this biodiversity, where there are interlinkages between markets in terms of biodiversity, which are very big. And so this is a first approach, but the idea to present this to you is indeed that you play with it, that you use it, that you even criticize it, so that we can actually start discussing which is the best way to discuss about it, the best way to incorporate this very, very detailed data on some indexes and some ways of measuring these long-term physical risks. And just to give you a flavor, but this is not from the data, it's really from the paper, we look into to which extent this trend has an impact on different sectors. And we find that some sectors are very impacted, while some others, like data centers, are not that much, right? So yeah, feel free to go look into the paper, which is open source, and to contact me if you have any ideas, questions, or remarks.
Thank you, Maria Eugenia. Very, very interesting. A quick question is, obviously, natural capital or research on natural capital is getting traction in the scientific community and academic literature. But do you see, coming back to our question on the missing data, and the field is amazingly complex and sophisticated, and it's getting more and more sophisticated. So do you think that the lack of data in some fields is basically blocking or limiting the scope of the research for you or your other colleagues?
I think it is. I think that, for example, we jumped into this biodiversity. So the first thing is trying to, and so the definition is by itself quite difficult, because people don't really understand what biodiversity means, why this is important. Are we talking about species? So the definition is quite large, and so once we get into, so we clean the way, we pave the way, and we say, well, we are economists, we are interested in to which extent ecosystem services. So we take this definition of how the ecosystems are giving services to the economy. We try to understand which data we have and how can we match this with firms. And we can do this for some regions or maybe some countries in collaboration with, but if we want to do something like this, where we want to understand, for example, most firms having a very international portfolio, this is a very challenging issue. And so we are blocked in many ways by the lack of data, the lack of comparability between data. So there are two schools. I believe that it's better to start with something and to show, well, look, this data is not perfect. It's quite aggregated. There are many issues to it, but we already find impacts on what we can measure, which means that if we dig deep dive, we are most probably going to find more impacts, heterogeneity in their impacts, and so on. So let's go for it. Let's go and try to get that data. Let's collaborate and start building data, open source, and so on. But definitely, we do have a data problem that we need to fill in.
We're ready to take your questions, but I'd just like to first take some from the chat. There's one easy I can answer myself, and the second one will be for Imen. The question is Pladifes data research project focused on Europe only or global? I think it's pretty clear from Thibaut, Capucine, and Theo's presentation that it is really global. The emission database is more than 50,000 companies. Capucine has shown that she's looking at the issue from every part of the world, and Theo's research was really focused on non-European areas. So I think we have an answer for that. The second question is on for Imen. There are many papers, research papers on methane direction using remote sensing. What is unique to the method developed by BNP Paribas?
Yeah. Thank you for this question. Indeed, satellite images have been explored now for years to quantify methane emissions. Most scientific papers that I read are about quantifying methane emissions from a region or a country and comparing it to the disclosure of the country or the region. Some of them are focused on the asset level, but within a given country or region. To my knowledge, our project is the first one where a financial company tries to compute the emissions at a global scale and at the company level. So this is something that I haven't read for the moment. So a global coverage, also the company level, and we compare different sources of methane emissions. So this is R&D work. The idea is to check and to understand the limitations of the technique and to draw conclusions from it. So this doesn't mean that the data points that we got are ready for use. So this means that we understand now the limitations of this technique, and we have few intuitions of where we should land when the data will be available at the company level.
Thank you, Imen. Another questions. Try to be short in the question and the answer, because these are the obstacle to our glass of champagne, or maybe a proxy of champagne, let's see.
I will try to be as efficient as possible. Thank you very much for the roundtable. Very interesting. I have a question and a meta question. A question for Guillaume and a meta question for Stefan. The question for Guillaume. Thank you very much for the presentation. Very interesting. I wonder if the data that you use from a qualitative perspective can be somehow transformed in something more quantitative using data from, for example, a community innovation survey or the innovation surveys of the European Investment Bank that takes into consideration the investments that companies have already done in green innovation, in circular economy, and then maybe you can extrapolate or use, I don't know, propensity score matching or matching techniques in order to extract that information from those surveys and add it to the analysis that you are doing, because I think all this climate analysis that we are doing with firms in terms of transition and physical risk kind of lack this idea of eco-innovation that we should all promote at the firm level. Thank you. And the meta question, I really want to thank the Pladifes team for putting this at the serve of academics, policymakers, and so on. My question is, how can you ensure the continuity of these very useful data sets in the future? As myself have worked in European projects, normally these projects, the funding finished, and then we don't refresh data sets and so on. Can we be sure that these data sets remain available and up to date for the actual analysis that we will need to do in the future? Thank you.
Thank you very much for the question. This is something we are, of course, trying to do, to use as much as available data everywhere it is to fill in the gaps we might already have. And our first goal is to avoid questioning a company where we can already access the data. You spoke about the innovation database of the EIB, for instance. So one particularity, so far we are focused in France. So France, in terms of economical sector, is very concentrated. So 300 companies are doing like a third of the value added. And so we are trying to help as much companies as possible. So notably, very quickly, we go further down and though we reach SMEs, basically, which the reports in terms of innovation and financial data related to innovation to SMEs is less available, to not say that it's not available. Still, so we take into account innovation because some of the questions we raise are basically, what are your level of decarbonization? So already the question of carbon storage comes very quickly in the aluminium sector, for instance. So how we can assess that, it's very difficult. And I would like to answer like one last thing. We have many debates within the team about taking into account what can be said tangible actions, I said, and intangible action. How do you take into account innovation when a company tells you, so far I'm not able to decarbonize, but I put money to innovation center, in 10 years I will be below my sector. So far, we don't take that into account because we cannot assess that at the time horizon we have, 3 years. But it's still a debate. We would be very happy to take it into account. So basically, to summarize, we know that we still have a lot of work to do. One of the streams is related to the question you raised about how to take into account innovation. Thanks.
Yes, and I'll answer for the question about the permanency of the Pladifes project and about the project, the databases. So the idea is that it's of course a constant fight to have to be financed in order to have this kind of open database and databases that are focused for academics and that are more accessible, free, or at least just to maintenance fees, where the fees are reduced as much as possible. So the hope that we have is that, for instance, Eurofide is doing this for financial data since 2003, so it's more than 20 years. So it proves that it's feasible to have this kind of business model, maybe not generating profits, but it's not the goal, but just to have this kind of thing in the long term. The main idea that we have is that this Pladifes project is not alone. It's part of Institut Louis Bachelier. And within the Institut Louis Bachelier, we have entities such as PARC, which is like a dedicated network on research on sustainable finance. And there is like a patronizing for this kind of foundation. There is also the Louis Bachelier Data Lab. So it's missions with practitioners, and it can help recruiting and having the teams that will keep the databases up to date. And also another way is to try to capitalize on the open databases. There are more and more databases that are accessible for free, and we try to first take a look at them before going towards like private ones such as Bloomberg, FactSet, where of course if you want to use this data and to redistribute it later on, it's of course much more complicated. And I hope I answered your question.
Yes, you're right. It's an ecosystem by itself, and it works together very well, and will be there as long as all the issue that we described will not be solved. So we're there for a long time. Questions? Capucine.
Thank you. Just a quick question from Maria. Thank you for your presentation. Can you just explain more in detail how do you link the biodiversity risk with sector impact, and which sector is the most impact after the agricultural one?
Yes, so I didn't put a lot of accent there because this is actually mostly in the paper and not in the database. So the database stops at sharing the trend that we estimate for two ways of estimating the trend for each country in time, and then the index also. So in the database there is the index and then the trend of the index. But then in the paper, what we actually do is to understand in different indicators of profitability. So different sectors, firms that belong to different sectors, to which extent their profitability is impacted by the trend in the country where they have their assets. And so we find that there are some sectors, mostly the ones that are related to agroalimentaire. How do you say that so the whole value chain, and not just agriculture per se, that are mostly affected. Negatively affected, and other sectors, the most clear one would be data centers, for example, another type of these digital world services that are not affected. And because we then classify the sectors into the mostly affected and the least affected, but this is part of the part of the paper, and not, which is in any case available online already, but it's not in the database because the database is mostly for you guys to use it in the way you want and in the way you find it useful. So yeah.
Thank you.
There are one more questions. Are you eager to move to the? You can ask questions to you between yourself. Just go ahead.
No, sorry, just one remark related to the question that has been raised about disaggregation or aggregation of data. I heard your answer, Thibault, and I fully agree about the technical difficulty of aggregating GHG emission. However, I really believe that we must do it. We must do it to show what is happening, and the situation you are presenting regarding biodiversity and the trend you are presenting are key to help move companies, public authorities, etc. So about us, when we will gather enough data, we will try to aggregate, and we will try to have a methodology that is robust enough to pass the Thibault test.
Now, this is a very good point, and it's an opportunity to say that we have also a project on aggregating emissions, consolidating also financing. Actually, will be very interesting in your financing data. That looks very granular and very interesting. So this is also part of one research project at the ELB Park on Pladifes. Do you want to have a conclusion? I mean, my conclusion was we have the brains here, definitely. We're just missing the data, and we're missing a glass of champagne.
Yeah, I mean, I'm not going to be long. I believe that we talked a lot. It was really interesting. Like maybe a quick conclusion would be that if we go back to the title, The Next Frontier in Sustainable Finance, Research and Data Needs, we already have a lot of data available. It's also how to exploit it, how to better exploit alternative data. I'm glad that we didn't hear too much AI tonight, because that's a word that we hear a lot, but I guess it will have its use cases, and for other use cases, it won't be enough. We talked a lot about environment, sustainable finance. In sustainable, you usually put more things than just environment, but maybe that would be a topic for a next event.
Yeah, no, that's very clear. I mean, Imen and Guillaume at least have been very clear. What they want is corporate data. This is a graal. Thank you very much, everyone, and we're waiting for you at the lunch on next to. It's happening at the Corbeil.
There is a cocktail in the Corbeil
just
next door.
No, so it's on your way out.
Yeah, you can't miss it.